Right triangles have a very special property. If you take the squares of the two shorter sides and add the results, you get the square of the longer side of the triangle. In this video, I'll be teaching the following: what the Pythagorean theorem is, and how we can use it. So let's start with some terminology. If you have a right triangle sitting flat on the ground like this, the bottom side is the base, the side perpendicular to the base is the perpendicular, and the longest side of the triangle is the hypotenuse. So what's the Pythagorean theorem state? The Pythagorean theorem states that a squared plus b squared equals c squared, where a is the perpendicular, b is the base, and c is the hypotenuse. In other words, the Pythagorean theorem states that the square of the perpendicular plus the square of the base equals the square of the hypotenuse. So here's the animation played at the beginning of the video, in case it helps you understand what the Pythagorean theorem is. And I'll just play it one more time. So, with all this in mind, let's solve some problems together. So one use of the Pythagorean theorem is that it can be used to find missing side lengths of right triangles. So let's say we have a right triangle here. We have the side lengths 3 here and 4 here. So we want to find the missing side length. So let's remind ourselves that the Pythagorean theorem says that a squared plus b squared equals c squared. And also, let's remind ourselves that a is the perpendicular, b is the base, and c is the hypotenuse. So, we have the base. The base is just the lowest side of the triangle, so its side length is 4. So we can plug 4 in for b, and our perpendicular is the side perpendicular to it, so its side length is 3. And the hypotenuse is c, and we don't know what c is. That's what we're trying to find, so we'll just leave the c squared as c squared. So from here, we can do a bit of solving. So 3 squared is the same as 9, 4 squared is 16, and then we can add 9 and 16, which gives us 25. So now we have a value for c squared, but remember, we need to find what c is. So the way we do that is to take the square root. The square root of 25 is 5, of course, because 5 times 5 is 25, and the square root of c squared is c, because c times c is c squared. So now we have our answer. The hypotenuse of this triangle has the length of 5. So let's try a different problem. Let's say we have the perpendicular can be 10, and then we can make the base 3. So let's plug in our values just as before. So we have 10 for a, and 3 for b, and we'll set it equal to c squared because that's what we're trying to find. And then we can take 10 squared, which is 100, and 3 squared, which is 9. We can add those numbers together to get 109. And now, just as before, we'll take the square root. So in this case, c is equal to the square root of 109. Now, because 109 is not a perfect square, we'll just leave the answer as that. So no whole number can be multiplied by itself to get 109, so we just leave the answer as the square root of 109. So now, let's try and find a missing side length of, well, a different side of the triangle. So let's say we already have our side length for c, and let's say we have our perpendicular, which would be 24 in this case. So notice that when we did the other two problems, let's just take the last problem for example. We plugged in our values like this, and notice this whole left side here we could simplify into 109. So we're going to want to do a similar thing. So we have our base here. So when we solved for c in that last problem, we had c squared right on the end here. So because now we're solving for b, we're going to want b squared on its own. So the way we can do that is we can subtract a squared from both sides here. And that gives us b squared equals c squared minus a squared. So now we have this b squared on its own, which is what we want. So let's plug in our values. C is 25, so we'll have 25 squared here. And a is 24, so we'll plug that in. Now you may not know these values off the top of your head, so I'll just do them out on the side here. 25 times 25 would be equal to 625. So we have 625 minus 24 squared. So I'll multiply that out. So that gives us 576. So now we can just subtract these two values, and I'll do that out as well. So 625 minus 576, that gives us 49. So b squared is equal to 49. And now, this looks pretty similar to when we were solving for the hypotenuse in the other two problems. So let's just take the square root of both sides. The square root of b squared is b, and the square root of 49 is 7. So we have our answer. B is equal to 7. So let's do another problem. I'll just remove all this real quick. Let's say we have this triangle here. This side can be 13, and we'll have, let's say, 10. Our side length here will be 10. And now, you may notice that our perpendicular is the missing side this time. So, just like we did before when we got the b squared term on its own, now we want to get the a squared term on its own. So if we just subtract b squared from both sides, we get a squared equals c squared minus b squared. So now a squared is on its own, so we can start plugging in our values and we can get an answer. So c is equal to 13 and b is equal to 10. And you may not know 13 squared off the top of your head, so I'll quickly do it out here. And we get 169, and then 10 squared, of course, is just 100. So now, a squared is equal to 69. And just like before, we'll take the square root of both sides. Square root of a squared is a, and 69 is not a perfect square, so we'll just leave it as is. So our side length here is just square root of 69. Okay. So we know how to solve for different side lengths, missing side lengths of a right triangle. What happens if we have all the side lengths given, but we don't know if it's a right triangle? Well, if you remember, the Pythagorean theorem can only be applied on right triangles. Which means, if you have a right triangle, the Pythagorean theorem will apply to it. If your triangle is not a right triangle, the Pythagorean theorem will not apply to it. So, this will be a little more clear once we start plugging in our values. So A is 6, B is 8, and C is 10. We can solve these squares, and 36 plus 64 is 100. And we end up with a true statement. And because this statement is true, we can say this is a right triangle. If the statement was false, we would not be able to say this is a right triangle. In fact, we'd have to conclude that it is not a right triangle. So, let's quickly do another example. If we have 8, 5, and 13. Actually, let's go 14. We can plug in our values just like we did before. So we have 8 here, 5 here, and 14 here. We can solve for our squares. 8 squared is 64, and 5 squared is 25. 14 squared you may not know off the top of your head, so I will quickly do that out right now. And we get 196. So now if we add 64 and 25, we will get 89. And we get a questionable statement here, because 89 is not equal to 196. And because the statement is false, we can say that this triangle is not a right triangle. So, let's quickly recap what we've learned. So, we can solve for missing side lengths, and we can also determine if a triangle is a right triangle. And if you're not sure on how to do any of these things, rewind the video, rewatch any segment you're confused on, and if you're still confused after that, you can put a comment on this video and let me know so I can explain it differently. So now that we've done some problems together, I'll give you your own problems to solve on your own, so I can see how you've done. Firstly, solve for the hypotenuse of this triangle, with side lengths 5 and 20 given. Secondly, solve for the perpendicular of this triangle, with side lengths 15 and 11 given. Lastly, determine if the following triangle is a right triangle. It has side lengths 5, 12, and 13. Thanks for watching. Put any questions, comments, criticisms, or future video suggestions in the comments section of the video. Or you can email me if you want. And consider subscribing to my channel if you enjoyed what you saw. It helps me out a lot, and it encourages me to continue making videos like this. In the next video, we'll determine how the Pythagorean theorem can be used to create the distance formula.